Hello everyone, I know that many of you were hoping to take a retake on Module 5 and we're not able to because of school closure. So I'm going to be making some videos on some of those concepts for you to review to hopefully when we come back to school that you'll have a chance to complete that retake. So the first one I'm going to be doing right now is based on the substitution method of solving systems equations. So I have two examples here. This first one here, on the left, the two equations of the system are x equals 2y minus 1 and 3y minus x equals 4. And so our goal is to solve this system, and what it means to solve is to identify where those lines would intersect on a graph. So if we imagined these lines as a graph, on an xy graph, and if we graphed both of these separately on a graph, and I'm not going to do them exactly because this is just a sketch. The way we can imagine them is having one line like this and another one like this. And then where those lines intersect would be the solution. And that solution would have an ordered pair of some x value and then some y value. And we can write that as an ordered pair like that, or like x equals and then y equals, and that would be whatever those values are on the coordinates. To do that, the substitution method, what we can do with that is this first equation here, x equals 2y minus 1. We know that x is equal to 2y minus 1, and so we can make a replacement or a substitution in this second equation. And so this, we know that 2y minus 1 is equal to x, and so in this equation we can make a replacement, a substitution for x. So we're going to rewrite that second equation with that substitution. So the equation is 3y minus x, except that we know x is equal to 2y minus 1. So, but we're subtracting it, and so I'm going to put parentheses around this to preserve our positive and negative signs. And so I'm going to subtract my value of x, which we know is 2y minus 1, and that's from the first equation. And we're going to finish writing this equation, the second one, which is 3y minus x. This is representing x here, and it's equal to 4. Now, from here, we want to solve the equation by combining like terms. We're going to be solving for the value of y, since y is the only variable. So we have 3y minus this expression in the parentheses. So we're subtracting 2y. Subtracting 2y is negative 2y, and we're subtracting a negative 1, which would be adding 1. That equals 4. And now I can combine like terms, so 3y minus 2y is 1y. And then I can solve for y by subtracting 1 from both sides of the equation. And I get 1y equals 3. So now I have the value of y, but I don't have the value for x. And to do that, I can use this number in either of these equations. I'm going to use this first equation here because it looks a little bit more easier to use, but you could use either one. And so the first equation is x equals 2y minus 1. However, we know that 1y is equal to 3. So I'm going to make a replacement here, another substitution in for y. So x will equal 2y, but I'm going to replace it with a 3 because y equals 3, and x equals to 6 minus 1, which is 5. So our solution then would be 5, 3. As our ordered pairs, we write them as x, y. So that would be the solution. So the second problem over here on the right is the one that's a little more complicated. And the main difference here is, you notice here, this x didn't have a number multiplying it. This one over here we have our equation equal to y, and in the second equation, y is being multiplied by 2. So the strategy and the approach you can take to this is we still need to rewrite this the equation by making a replacement. And so, but we're replacing just the y, not the 2. And so I'm going to rewrite the equation, and it's going to be 2. And then we need to preserve that value and the signs of y. So I'm going to put parentheses 2. And it will be negative 3x plus 2. And then we continue writing the equation, plus 4x minus negative 4. So from here, we continue like we did over here in solving and combining like terms. However, when I have this situation here, when it's 2 times this value in the parentheses, we need to distribute that value of 2. Just like over here, we distributed this negative to each of the values in the parentheses. So 2 times negative 3x is negative 6x, and 2 times 2 is 4. And I continue with the equation. And now I combine like terms. So negative 6x and 4 are not like terms, as they don't both have x, but negative 6x and 4x are like terms, so I can add those together. Negative 6 plus 4 is negative 2, so it would be negative 2x. And I still have this plus 4 equals negative 4. Now I got to solve for x, so I subtract 4 from both sides. Negative 2x equals negative 8. I'm going to divide by negative 2. And that means x is equal to 4. A negative divided by a negative is a positive. So now I have my value of x, but I don't have my value of y. And so I'm going to use, I could use either equation, but once again I'm going to use the first equation because it's equal to y, and it'll make it easier to find my value. So I'm going to rewrite that first equation, y equals negative 3x plus 2, and x is equal to 4, and so I'm going to make a replacement here with x. So y equals negative 3 times 4, because x is equal to 4, plus 2. And then I'm going to solve this algebraically. Negative 3 times 4 is negative 12, plus 2. And then y equals negative 12 plus 2, which would be negative 10. So my solution, the ordered pair, would be 4, negative 10, since the combination is x, y.